In this task, we're going to develop a custom large language model that extracts information from its Jane website. This model will answer user questions related to this company dedicated to online cake sales. We will program to process to automatically pull information from the website, and additionally, we will try to prevent model hallucinations. The first thing we're going to do is create a new chat flow. To this chat flow, we need to add a large language model, which in this case could be, for instance, the ChatGPT model. On the other hand, we'll implement the part corresponding to information extraction through web scraping, and finally, the storage of the information in a vector store. We'll start with OpenAI's ChatGPT model. First, we'll have to add its credentials. Next, we'll handle the web scraping part. If we search for the word scrapper, we'll find different tools for this task. Although we'll select one in particular, several of the available options would be suitable. Once we choose the tool, we provide the URL of the website we want to extract information from. After that, we need a text splitter. This is because if the extracted information exceeds the model maximum token count, the splitter will divide the content. Therefore, we'll add the HTML to Markdown text splitter. So, if the information obtained surpasses, for example, 1000 tokens, it will handle the splitting and prevent exceeding the maximum token count allowed by the ChatGPT model. Next, we'll address the chain, a chain that allows linking different components. In our case, we'll select one specific. To this chain, we will have to connect the large language model, the vector store, and optionally the memory path. Regarding the vector store, we'll choose Pinecone, although there are several options we have seen before. An embedding is also required. In this case, we'll opt for OpenAI's. After adding the credentials to the embedding, we'll connect it. Instead of a proper source document, we will use the web scraping result. Thus, we connect this output to Pinecone. We also need to add credentials to Pinecone and generate some indices. Once this is done, we can connect it to the chain and save the project. This configuration is basic, and in the next task, we will discuss how to enhance it. Finally, we will test our system to ensure it works correctly. We have different menus for inquiries. Although the first option doesn't provide an answer, by specifying the query, we obtain the desired information. If we visit the page, we can verify that the system responds adequately. Thus, we conclude that the project works as expected. In this video, we're going to explore how to implement a series of improvements in the previous project. The first improvement is related to the web scraping part. As it is currently programmed, it only focuses on the main page. However, we wanted to scrape all the subpages derived from this main page to gather as much information as possible. How should we program it? To achieve this, we need to go to Additional Parameters and select the Web Crawl option, so it scrapes not just the main page, but also its subpages. Afterwards, we can determine the number of relative pages we want to be processed. If we set the value to 0, it will take all of them, but keep in mind that this might increase the processing time. Having adjusted the scrapping part, we move on to modifying the model. Specifically, we are going to check the conversational retrieval quality chain to give certain guidelines to the model, aiming to prevent hallucinations. We do this from Additional Parameters, where we can add a message for the system. We'll instruct it to act as an assistant that provides answers, and if it doesn't have the requested information or doesn't know it, to respond indicating it is uncertainty. In this way, we prevent the model from providing invented or erroneous answers. Additionally, we'll activate the Return Source Document option, allowing the model to include information directly from the web when responding to the user, making its answers more informative. After these adjustments, we'll proceed to test the system again. However, before making any inquiries, it is crucial to save the project to ensure that all modifications are applied correctly. Once done, when posing a question to the model, we'll see that it provides us with more comprehensive answers and also includes additional elements directly extracted from the website. Identify the key steps it needs to complete. In this task, we'll explore some alternatives on how we can obtain a personalized assistant that learns from the information present on the internet from our HCI center, albeit with a slightly different configuration. Just like in the previous task, the first step would be web scraping. As we mentioned, we have used Serial Web Scrapper for this. However, we could also choose Playwright or Puppeteer Web Scrapper. Both are quite similar to Serial and offer us similar functionalities. On this occasion, we will choose, for example, Playwright. We could provide it with a URL, and in the same way as we did before, we would link it. The next step would be to set up the database, in this case Pinecone. However, as we well know, there are other store vectors we could use. Subsequently, we would integrate the large language model, in this scenario ChatGPT. We are endowing this model with additional memory through the Motorhead module. As detailed on the Flowise page, Motorhead is an open source project that allows providing memory to large language models. Here, its utility is demonstrated. A series of questions are posed to the assistant, and then it is asked about what it had been previously questioned. In this way, the assistant can remember the content of the conversation. This aspect is crucial when we want to implement personalized chatbots that interact with users. Therefore, it is advisable to integrate a memory module, such as Motorhead. We would need to introduce the corresponding credentials, and if using the online version, we wouldn't have to specify anything in base URL. On the other hand, if we decide to opt for the local version, we would have to introduce the corresponding URL for Motorhead. This proposal would be an alternative to the initial project of developing a personalized model that learns directly from the HCI website. And, although there is another alternative that might not be as efficient, in this second approach, we would have a conversational agent that would track the required information on the internet. For example, if we were asked about the menu on the HCI website, we would probably access that site to get information. However, we cannot assure this with total certainty.